Hello everyone. I have posted the quiz results, and you can check the scores of your quiz result. And in each week, the quiz will has 3 questions, and each question is worth 25 points. And attendance is also worth 25 points. So the total points of a quiz are 100. And I also posted the results of assignment 1. And if you have not sent the assignments, the deadline is 12 p.m. Today. And in the previous week, we have learned the branching mechanism and the while statement. And in this week, we will learn the for statements and the break and continue statements. And let's see the comma operator. The comma operator is this symbol. And the purpose of the comma operator is to evaluate list of expressions. And the comma operator will return the value of the last expression. And for example, consider this example. Before the comma is an assignment, we assign 2 to the variable first. And after comma is another assignment. We assign first plus 1 to the variable second. And the comma operator will return a value. So what is the value of this expression? The value of this expression is the value yielded by the last expression. So the comma will return the value yielded by this assignment. Yes. Do while. I will skip the do while statement, and because you can always use the while statement to replace do while statement, and the do while is very similar to while, so I think you can learn the do while if you are interested. So I will skip the do while statement. Because you can always use while to replace do while. And due to time insufficiency, so I will not cover the do while statement. And for the comma operator, it will yield the value of the last expression. And in this example, the last expression is this assignment. And the value of this assignment is is the value of first plus 1, or the value of second. So the value of this expression is 3, because 2 is assigned to first, and then 2 plus 1 is assigned to second. So the value of this the value of this expression is 3. Then 3 is assigned to result. So both second and result get assigned the value 3. But it is not recommended to write your program in this way, because this way makes your program hard to read. You had better to split this line into 3 lines. The first line you can assign 2 to first, and the second line you assign first plus 1 to second, and the third line you assign second to result. So it is better to split this line into 3 lines. This will make your program more readable. And next, I will introduce the for statement. And let's revisit the while statement first. For the while statement, after the while keyword is a parenthesis, and inside the parenthesis is a Boolean expression. And if this Boolean expression is true, then the program will enter the loop body. So if the Boolean expression is true, then the body statement will be executed. And then the Boolean expression will be tested again until the Boolean expression is false. If the Boolean expression is false, then the while loop will be terminated. Let's see the syntax for the for loop. And for is a keyword, and after the keyword is a parenthesis, and inside the parenthesis there are 3 parts. The 3 parts are separated by the semicolon. And the first part is the initial action. The second part is the Boolean expression. And the third part is the update action. And first, the initial action will be executed before if the program executes the for loop. first the initial action will be executed. Then the program will check the Boolean expression. If the Boolean expression is the second part, if the Boolean expression is true, then the body statement will be executed. And after the body statement is executed, then the third part of the third part update action will be executed, and then we go to the Boolean expression, and the program will check the value yielded by the Boolean expression. If the value yielded by the Boolean expression is true, then the for loop will continue. But if the value yielded by the Boolean expression is false, then the for loop terminates. And I will use an example to illustrate how to use the for loop. And let's consider this example. I will copy the source code of this example into the online IDE. And let's compile this program and see the output. And first, I declare two variables. The initial value of sum is 0, and the initial value of n is 1. And there is a while loop. And inside the parentheses, we test we check whether n is less than or equal to 10. If this is true, then the body statement, here the body statement is a compound statement. The compound statement is enclosed by the two braces, and inside the braces are two statements, and the compound statement is called the body statements. And because the value of n is 1, so the Boolean expression is true, and the body statement will be executed. And the value of n will be increased by 1. And then the program will check the Boolean expression again, and until this Boolean expression is false. So when the value of n is 11, then the while loop terminates. So when the while loop terminates, the program will go to this line. So when you print the value of n, the value of n is 11, and the value of sum, and you need to calculate the value of sum. in each iteration, the value of sum will be increased by n. And n is from 1, 2, 3, 4, 5 to 10. So the value of sum is 1 plus 2 plus 3 plus up to 10. So the value of sum is 55. And this is an example to use the while loop. And we can rewrite this example using the for loop. And typically, we can rewrite this example using the for loop. And let's see how to do it. So for the inside the parentheses of the for, there are 3 parts. So the 3 parts are separated by 2 semicolons. And for the initial action, I initial the value of n. And for the Boolean expression part, I copy this Boolean expression to the second part. And for the update action part, because the body statement increase n by 1, so I put plus n in the update action part. And then we need to add the body statement. And the body statement is the same, so I copy the body statement. And you can use the beautify icon to format the source code. And if we compare the for loop and the while loop, you see that I initialize the value of n in the initial action part. So I initialize the value of n in the initial action part. And the second part is the Boolean expression. And this Boolean expression is the same as for the while loop. And I put the last line. I put the last line of the while loop in the update action part. And we can compile this program and to see the result. And you see the result is the same as using the while loop. After the for loop, the value of n is 11, and the value of sum is 55. Oh, okay. I will call the teaching assistant. I will call the teaching assistant to turn on the air conditioner. And if we compare the two examples, the two examples, you will find using for is more readable. And we know that here n is called the index variable. And later when we learn array, we often need to use an index variable. And here n is the index variable. And the index variable has an initial value, and in each iteration of the for loop, the index variable will be increased by some value. And we see that we only update n inside the parentheses, while in the right hand side example, we update n in different locations. And so the right hand side example, on the right hand side example, it is more difficult to read, because you need to, if you want to keep track of the values of n, you need to search where is n. If we want to keep track of the value of n, then for the right hand side example, you need to search the locations of n. But for the left hand side example, it is clear that n is only inside the parentheses. So for the right hand side example, it is more easy to read. And it is convenient to use for to process arrays. So if we want to process array, we often use the for loops. And we can to understand how to use for loops, you can also print the value of the index inside the body statement. And I add one line inside the body statement to print the values of n and the sum. And I forgot to add a semicolon. And below is the program output. We see that for the first iteration, the value of n is 1, and the value of sum is 1, because sum is sum plus n, and the initial value of n is 1, and the initial value of sum is 0. So for the first iteration, the value of sum is 1. And it is important to give initial values to variables. For example, if we forgot to give initial values, then let's see what will happen. In this example, it makes no difference, but sometimes you will get wrong results. For the first iteration, the value of n is 1 and the value of sum is 1. And for the second iteration, the value of n is 2 and the value of sum is 3, because the value of 3 is sum plus n. And in the previous iteration, the value of sum is 1. And for this iteration, the value of n is 2, so 2 plus 1. And in the second iteration, the value on the right-hand side is 2 plus 1. So in the second iteration, the value of sum is 3. And the iteration continues until the Boolean expression becomes false. And when will the Boolean expression becomes false? When n is 11. When n is 11, this Boolean expression becomes false. So the last iteration is this line. The last iteration is n is 10 and the sum is 55. And when n is 11, Boolean expression is false, and the for loop terminates. And when the for loop terminates, we will go to this line. And this line, the program will print outside for. So outside for, n is 11, and the value of sum is 55. Let's go to the next slide. And in this slide, there are two ways to produce a loop. By a predetermined number of times. There is an index variable count. And for the first example, the initial value of count is 1. And the Boolean expression is count is less than or equal to 3. And in each iteration, the value of count will be increased by 1. So you can count how many times the body statement will be carried out. The body statement will be carried out 3 times because count begins from 1, and if count is less than or equal to 3, the body statement will be executed. So the body statement will be executed 3 times. And you can also change the initial value of count. For example, I can change the initial value of count to 0. And suppose we want the body statement to execute it 3 times, and this time the Boolean expression is changed to count is less than 3. And you can verify that for the second example, the body statement also executes 3 times for count from 0, 1, and 2. And for this example, we see that the body statement does not use count. For this example, the body statement is cout, and we don't use any of the loop control variable. And here the loop control variable is the index variable count. So in the body statement of the for loop, you don't need to make any reference to a loop control variable. You can use the control variable, but it is not necessary. And in this slide introduces a common mistake about using the for loop. And if you add a semicolon after the parentheses, and this is legal syntax. This syntax is legal, but this syntax will produce a semantic error. And let's see what will happen. So I copy the two lines into the IDE. I change the Boolean expression because this will facilitate the output. And for this example, the for loop has 3 iterations. So hello is printed 3 times. But if we add a semicolon right after the parentheses, and let's see what will happen. And if we add a semicolon right after the parentheses, then the program only outputs hello for one just once. So if we add a semicolon right after the parentheses, the program outputs is not what we expect. We expect the program to print hello 3 times. So what happens? And we know that this is legal because the compiler did not produce any error message. So this syntax is legal. And because the semicolon will create the empty statement or the null statement. And for this example, the body statement of the for loop is empty, or the body statement of the for loop is the null statement. Because the body statement is the one between the parentheses and the semicolon, and it is empty. So for this example, the body statement of the for loop is empty, and therefore, the for loop actually do nothing. The for loop does not do anything. Then the for loop terminates. And after the for loop, the program will print hello. So the correct indentation for this example is this one. This is the correct indentation. After the for loop, hello is printed. So this is the correct indentation. But if we remove the semicolon, then the correct indentation should be this one, because CL is inside the body statement of the for loop. So for this example, the program will print hello 3 times because CL is inside the body statement of the for loop. And you can try to use your compiler to compile this example. And if you add a semicolon and you click beautify, you will find the indentation. Indentation becomes this one. But if you remove the semicolon and then you click beautify, then the indentation changes because the syntax changes. And let's see another example. For example, the next example is also about mixed semicolon. For example, if we add a semicolon right after the parentheses, and for this example, this example will create an infinite loop. An infinite loop means the loop never terminates. And we can copy this example to the IDE. This is the normal example. I remove the semicolon. This is the normal example. And for the normal example, the program outputs enter value. Then I will input some value. For example, I input some value. then this value will be saved in the response variable. So my input will be saved in the response variable. And after I enter a number, then this number is saved in the response variable. And if the value of the response variable is not 0, the while loop continues. So if I enter another number, if this number is not 0, the while loop continues until I enter the number 0. If I enter the number 0, then the while loop terminates. And you see, when I enter value 0, then 0 is saved to response. And the Boolean expression becomes false because if response is 0, 0 is not equal to 0. This Boolean expression produces false. So the while loop terminates. But if we add a semicolon right after the parenthesis, and let's see what will happen. For this example, stop. I compile again. Oh, I did not give initial value. I should give an initial value to response. And suppose the initial value of response is 1. You did not see anything output because we stuck in this line. Because this line runs forever, so we cannot see any outputs. Because the initial response is 1, then the Boolean expression is true, because 1 is not equal to 0. Then the while then this line runs forever. So we did not see anything. And if you want to see something, you can add some statement, because for example, you can and you can see that if I add one statement inside the while loop, and you find that the while loop prints hello, and this loop never terminates because the value of response is never 0. Because we have no chance to change the value of response inside the body statement. And for this example, the body statement is cout hello, and inside the body statement, we have no chance to modify the value of response. So the value of response if the value of response is not 0, then this loop will run forever. So the correct syntax, the correct semantics for this example is to remove the semicolon. The semicolon is not what we want. But if you accidentally add a semicolon, then this is legal syntax. But the semantic is not what we want. Sometimes, so the previous example produce an infinite loop because we make a mistake to control the Boolean expression. The Boolean expression is always true, so the loop runs forever. And this is called an infinite loop. We can deliberately to create an infinite loop. For example, you just put 1 inside the parentheses, because 1 means true. So this is equivalent to while true. And this loop will run forever. And this is legal. This is perfectly legal C++ loop. And if you want to terminate an infinite loop, you can type Control-C. For previous example, suppose I want to terminate the loop, then I type Control-C. And you see that if the program receives Control-C, then it will finish it. And for some applications, infinite loops are desirable. For example, for embedded systems. For example, if we use surveillance camera to record videos, and then the recording program need to run forever because the recording program need to record the videos. So sometimes, for some applications, infinite loops are desirable. And let's take a break for 10 minutes. And in the next hour, we will have a quiz. Hello, everyone. Let's continue our class, and we will have a quiz. So if you cannot use the Ruvio app, please raise your hand. What?
So we can use phone on that, right?
Uh,
How do I get it? Because I have to use it.
you should wait until I open the question. If I open the question, you will
I'll
see
see
it.
it. Okay.
Yes. And during the quiz, you cannot use the laptop computer, so you need to close your laptop computers. You can use mobile phone and see the previous slide. You can see the slides, and you can use the mobile phone, but you cannot use the laptop computers. Okay, then I will turn on the first question.
It says I already added to this course.
Oh yes, then you.
Oh, it's this. Okay. Thank you.
And 2 minutes left.
They wrote their name on my seat. Like I sit there, and then somebody wrote.
Oh, And 10 seconds left. And I will close this question. And the second question is asks you the value of y after the above statements. And 30 seconds left. And I will turn off this question. The third question asks you the value of bonus after the above statements. The initial value of bonus is 5. And 1 minute left. And I will turn off this question. And I will collect the paper, and you remember to write down your student ID and your name. Thank you. Thank you. And I will show the answer. Let's see the first question. The correct answer is 4. The result 1 is true and result 2 is false. And most of you choose the correct answer. And this question is about Boolean expression. X is not greater than y, so the first Boolean expression is false. And the second Boolean expression is true because z is greater than y. So result 1 is true because the OR, this is the logical OR. If any of the two inputs is true, then the output of the OR operator is true. So result 1 is true. And if any of the two inputs of the AND operator is false, then the output is false. So result 2 is false. So the correct answer is 4. And for this question, the correct answer is 1. Y equals 7. And the initial value of x is 10, and the 10 modulo 2 is 0. So inside this parenthesis, the result is true. So inside this parenthesis, the value is true, and the true is assigned to COND. So CIND is true, and if COND is a Boolean variable, its value is true. So the program will carry out the statement after if. So y the value of y is increased by 2. So 5 plus 2 is 7. So the correct answer is 7. Y is 7. Let's see the third question. For this question, the correct answer is bonus is 20. So this one is the correct answer. Not 30. Let's see why. The initial value of bonus is 5, and there is another variable day. The initial value of day is 11, and we will not go into the if statement because day is not less than 10. So we will go to the else if. We will go to the else if part, and you notice that inside the parentheses is an assignment. This is not a logical equality, and this is legal. This is legal C++. This is legal, so I can write C++ in this way. This is legal. If you assign 15 to day, then this expression will yields 15. So the value after the assignment is 15, and 15 is treated as true because 15 is not 0. So 15 will be treated as true, and therefore we will go into the else if statement. So bonus will be increased by 15. So 5 plus 15 is 20. So the correct answer of this question is 20. And so for every question you need to pay attention to the every symbol, and this question is actually mentioned in the previous slides. For example, this the question 3 is mentioned in this slide. And if you still have question, you can use a simple program. You can write a simple program to print the output of bonus. And let's return to our slides. Next, I will introduce two statements of the break and the continue statement. And let's see the break statement first. And I will use an example to use how to illustrate how to use break. And for this example is a for loop, and there is one index variable, iter, the initial value of iter is 1, and in each iteration the value of iter will be increased by 1, and the Boolean expression is iter is less than or equal to 10. So if this Boolean expression is satisfied, then the body statements will be executed. And inside the body statements is inside the body statements there are two statements. The first statement is if statement, and followed by a cout statement. And the if statement checks whether iter is equal to 3. If this is true, then the break statement will be carried out. When the program executes break, then the for loop terminates immediately. So if the program executes break, then the for loops terminates, and then the program will go to the statement after the for loop. So let's see this example. The initial value of iter is 1, and the 1 is less than or equal to 10. So we will enter the body statement, and first we check whether iter is equal to 3. And for the first iteration, iter is 1, and the 1 is not equal to 3. So break will not be executed. And then cout is executed. So hello will be printed. And after the body statement, the value of iter will be increased by 1. So the value of iter becomes 2. And again, we need to check the Boolean expression. And the 2 is less than 10. So we will enter the body statement. And we check whether iter is equal to 3. And the value of iter is 2, which is not equal to 3. So we will not execute the break statement. We will execute the cout. So the second iteration will print cout, will print hello. And after the body statement, we will the value of iter will be increased by 1. And this time the value of iter is 3. And the Boolean expression is true, because 3 is less than or equal to because 3 is less than 10. So we will enter the body statement. And this time iter, the value of iter is 3. So the Boolean expression inside the parentheses is true. So the break statement will be executed. And when the program executed the break statement, the for loop terminates immediately. So hello will not be printed. So there are only 2 hello printed. And then after the for loop terminates, the program goes to cout and print the value of iter. And we know the value of iter is 3, so the 3 is printed. And you can also print the value of iter inside the body statement. And you can also you can print the value of iter inside the body statement, and you can know in each iteration the value of iter. So when iter is 1, hello will be printed. Iter is 2, hello will be printed. But when iter is 3, this line will not be executed. So this example is about the usage of break. So the break statement completely ends the while loop or the for loop. You can use the break statement in the loop, in the for loop, or in the while loop, or in the do while loop. And there is another related statement called continue statement. And let's see if we change the break statement with continue statements, and let's see what will happen. And if we change the break statement with the continue statement, then the program outputs are different. For when iter is 1, hello is printed. When iter is 2, hello is printed. But when iter is 3, the program will skip the statements after continue. So when iter is 3, the program will skip this line because this line is after continue. And then the for loop is not terminated. The for loop continues. So the value of iter will be increased by 1. So the value of iter is 4. And then the loop continues. And if the value of iter is 4, hello will be printed. And again, the for loop continues. When the value of iter is 10, hello is printed. And when the value of iter is 11, then this Boolean expression becomes false because 11 is not less than or equal to 10. So when iter is 11, the for loop terminates. And if we print the value of iter after the for loop, the value of iter is 11. Because if the value of iter is 10, then we are still inside the body statement. So the continue statement merely ends one loop, its iteration. And if there is any next iteration, and the loop will continue. And in the bottom of this slide, there are 2 questions. What is the value of iter after the for loop? And we see that if for this example, the value of iter after the for loop is 3. Because when iter is 3, then the break statement is executed. And so for this example, the value of iter is 3 after the for loop. And you can use online IDE to test this example. So the value of iter is 3. And if we replace break with continue, and let's see if we replace break with continue, and what is the value of iter after the for loop? The value of iter is 11 because if we replace break with continue, the iteration will skip the third iteration, but the iteration will continue until the for loop terminates. When the for loop terminates, the value of iter is 11. So if we change break with continue, then the value of iter after the for loop is 11. So if we change break with continue, then the value of iter after the for loop is 11. And you can modify this example to test how to use the break and the continue statements. And next, I will introduce the nested loops. And here, nested loops means loop inside loop. For example, inside the for loop, I can add another for loop. So this is called nested loops. And you can also add another loop inside the for loop, the inner for loop. When we use nested loops, if you want to use break or continue, then the break or continue only apply to the innermost loop statements. Let's see one example. The indentation is not correct, so I need to manually do indentation. And if you compile this program, and you will see the outputs of the program. And if we add a break statement after cout, and let's see what happened if we add a break statement. And we see that it prints. I remove the break statement, and let's compile again. The program outputs 1 times 10 equals 10. There are two index variables. The first index variable is n, and the n begins from 1 to 10. And in each iteration, the value of n is increased by 1. And there is another index variable, m. The initial value of m is 10. And in each iteration, the value of m is decreased by 1. And until m is less than 1, then the inner for will terminate. So we will see the output of the program is the first number is n and the second number is m. So m begins from 1 to 10, and the value of m is the second number. The value of m from 10 decrease from 10 to 1. And this is for the when n equals 1, then m will decrease from 10 to 1. And for n equals 2, and again m will decrease from 10 to 1. And for n equals 3, and again m will decrease from 10 to 1. And if we add a break statement after the cout, and let's see what happened. And you see that the m did not decrease from 10 to 1. You see that m did not decrease from 10 to 1 because of the break statement. When m equals 10, then this line cout prints n times m. And after cout, the break statement is executed, and then the inner for loop terminates immediately. So the m will not decrease. So m will not be decreased by 1 because the break statement terminates the for loop immediately. And then after the inner for loop breaks, this break will only affect the inner for loop, and this break will not affect the outer for loop. So the outer for loop will continue. So after n is increased by 1, n equals 2. And then we enter the inner for loop and print 2 times 10 equals 20. And then we meet the break statement. And the break statement will terminate the inner for loop. And then we increase the value of n by 1. So when the value of n is 3, and you will enter the inner for loop again. So this example is to remind you that the break or continue statement only applies to the innermost loop statement containing the break or continue statement. So in this example, break only affects the inner for loop. So this break will not affect the outer for loop. And you can also test if you remove this break, if you change the location of the break statement. For example, if you add a break statement after the inner loop, and let's see what happens. And this time, you will see the break is to break the outer loop, but not the inner loop. So the inner loop will the inner loop will be executed. So you see the print, the program outputs 1 times 10, 1 times 9, and 1 times 1. And after the program executes the inner for loop, then the program executes the break statement. And this break statement will terminate the for loop, the outer for loop, immediately. So we cannot see n equals 2. Because if the program executes the break statement, then the outer for loop terminates immediately. So you can use this example to understand the behavior of break and continue statements. And sometimes you might want to break 2 loops. For example, you want to jump out the 2 for loops. And if you want to do this, you can use the goto statement, goto keyword. But this is not recommended. It is not recommended to use goto, so I will not introduce goto. If you want to break the 2 for loops, you need to add some if statements. For example, for this example, I want to terminate the 2 loops, and I add if statement inside the for loop. Inside the for loop, if the value of m is equal to 3, then the inner for loop will break. But this break only breaks the inner for loop. So if I want to break the outer for loop, I need to add another break statement. So this time I add one if statement. I test whether the value of m is 3. Because if this line is executed, then the value of m is 3. And after the inner for loop is terminated, the value of m is 3. So I check whether the value of m is 3. And if the value of m is 3, then I break the outer for loop. And we see that the program terminates when he executes this command. And after the for loop, I print the value of m, and the value of m is 3. And if you want to test the for loops, you can declare the variable in the initial action. For example, I can declare variable n and declare variable m in the initial action part. So for it, I remove the if statement. And if you want to show the results, if you want to print the value of m after the for loop, you will find the compiler will issue error message. It says m was not declared. You see, for this example, m was not declared because you can only use m inside the inner for loop. Because the m is declared in this, only declared in the inner for loop, so you cannot access m outside the inner for loop. So you cannot even access m after the for loop, after the inner for loop. If you want to print the value of m outside the for loop, you need to declare the value. You need to declare m in the beginning. So this time I declare m in the beginning, and there will be no error message. So it depends on whether you want to print the value of the index variable. And let's take a break for 10 minutes. Hello, everyone. Let's continue our class. And in this chapter, we learn Boolean expressions and the branching mechanism, including if-else and the switch statements. And we also learn the for loop and the while loop, and also the break and the continue statements. And the fourth part is about file input. And previously we have used cin, and the purpose of cin is to read inputs from users. And suppose we want to read inputs from a file on the disk, and then what will we do? And you can declare an input string like this one, and input if string is the input string. It is a data type defined in the IOString library, and I use this data type if string to declare a variable input string, and then I use this variable to call a function open, and then we need to give the file name of the file. So for example, we have a text file name .txt on the disk. Then we can use these statements to open this text file. And after we open the text file, then we can use input string. We can use this variable to read words from the text file. And in this example, the behavior of input string is like cin. So we can read the words of the text file we can read words from player.txt and save the words in the variable text. And so here the behavior of input string is like cin. We direct the output of cin to another variable, and here we direct the output of input string to a string variable. So the usage of input string is like cin. And but in order to use input string, you need to declare input string, and you need to associate the input string to a text file you want to open. And after you finish the use of input string, you need to close this input string. Because if you do not close this input string, the system will not release the privilege to use the text file. And if you are interested in if you are interested in more details about the input string, about file input, you can take a look at chapter 12. And next, we will go to the next chapter. And this chapter is about arrays. And what is arrays? Arrays means a collection of data type. Array means a collection of data of the same data type. And we often use arrays. Arrays are very useful. For example, if I want to write a program to, for example, I want to write a program to compute the scores of students. And for examples, there are 10 students, and therefore I will need 10 score variables. And another example is that if I want to compute the temperature of, if I want to compute the average temperature of this month, then I need to record the, I need to know the temperature of every day. So I need to save the temperature of every day in one variable. And this time we can use arrays. For this example, suppose there are 5 students, and therefore we declare 5 integer variables: score 0, score 1, score 2, score 3, score 4. And each variable will denote the score of a student. But if you write your program in this way, you will find this is very inconvenient. For example, if there are 100 students, you need to copy and paste 100 times. So this way can only work for a small number of students. If we use array, this syntax is to declare array, and this statement declare a variable score. Score is an array of integers, and to declare an array, you need to add brackets after the variable name. So after score are brackets, and inside the brackets is a number. This number is the number of elements in this array. So this statement declares an array of 5 elements, and this will allocates memory of 5 integers. And we can use an example to illustrate how to use the array. For this example, I want to read 3 scores from the user input. So for this example, I want to read 3 numbers from the user. For example, I type 357, and then I input 357, and 3 will be saved in score bracket 0, and 5 will be saved in score bracket 1, and 7 will be saved in score bracket 2. And after the cin, I print the values saved in the array. And it is convenient. If you have a lot of elements, you can write a for loop. So we can rewrite this statement using for loop. This statement is not convenient, because if there are 100 elements, then you need to add 100. You need to add 100 elements of the score array. So if there are many elements, then we need to replace this statement with a for loop. So I will use a for loop to replace this statement. And I comment this statement, and I use this for loop to read input from the user and save the user input in score bracket I. And you see that there is one index variable I, and I should begin from 0. Because the index of the array is always begins from 0. So here the initial value of the index variable is 0, because the index of the array begins from 0. And in each iteration, the value of I is increased by 1, and until I is greater than or equal to 3. And because the array has 3 elements, so here the index begins from 0. The index is 0, 1, and 2, because the score only has 3 elements. And we can compile this program, and this time similar to the previous example, I need to input 3 numbers. And after I type enter, and the program will will print the value of each element in the score array. And it is convenient that if you have a lot of variables, for example, if you have 100 scores, then you simply multiply the number from 3 to 100. Then you can input 100, you can read 100 inputs from the user. So when you need to deal with a lot of variables, we often use array because it is easy to deal with a lot of variables with array. You can use the for loop to access each element in the array. And in this example, I is called the index. I is called the index. And sometimes I is also called the subscript. So sometimes I is called index or subscript. And it is important to remember that the value of index is from 0 to size -1. So in this example, the value of I ranges from 0 to 99. 99 is 100 minus 1. So the range of the index is from 0 to 99. 99 is size -1. And if we want to access the element of the array, we also use bracket. For example, we want to access the fourth element of the score array, then we can use this. Expression. And it is important to distinguish between whether you are declare an array or whether you are accessing elements of an array. For example, in this statement, the number inside the bracket is 3. This number means the number of elements in an array. This is in this statement we declare an array. So when we declare an array, the number inside the brackets means the number of elements of an array. But when we want to access elements of an array, then the number inside the bracket means index. So here 0 is index, the index to the first element of the array. So the index can be 0, can be 1, can be 2, but the index cannot be 3 because 3 is outside the capacity of the array. So for example, if I change the declare, if I change the size of the array, let's see what will happen. I need to enter, for example, I enter 3 numbers. And you see that we can compile this program. The syntax is legal, but we encounter runtime. We encounter runtime problem. When we run this program, stack smashing detected, because the array only has 2 elements. So the index can be 0 or 1. The index cannot be 2, because the array only has 2 elements. And when I write this expression, this means I am accessing elements outside the array. The syntax is legal, but this will cause runtime error. This will cause runtime error like this one. And for this example, we shouldn't read the input of the user and save. We shouldn't access score bracket 2. We shouldn't access this element because the size of the score array is 2. But if you change the size from 2 to 3, then this program will run can run normally. So for this time, if I change the size of the array from 3 to 2, then the program terminates without any error message. So it is important to make sure that the index of the array begins from 0 and is less than or equal to size minus 1. So we have to distinguish the 2 uses of brackets. The first usage is in declaration. In declaration, the number inside the bracket means the number of elements of an array. And while besides declaration, inside the brackets means a subscript or an index. So for this example, the number inside the bracket means subscript or index. So we have to distinguish the two uses of brackets. And for beginners often confuse what is the number inside the bracket. And it is easy to remember. If it is in declaration, then the number inside the brackets means the size of the array. Otherwise, it means we are accessing the elements of an array. And the index or subscript need not be constant. So the index or subscript can be a variable. So in the two examples, the subscripts are variables. And the array is very powerful, and in every nearly in every program we will use array. And below lists some usage of array. For example, we can display elements of array score. We can fill elements of array scores. And we can also find highest or lowest value in an array. And in this slide, the first example is to read scores from the user. And so first, the first line, we declare a variable score. And this score is an array, so after the variable name is a bracket. And inside the bracket is a number. This number means the size of the array. And then we can write a for loop to access the elements of the array. Or you can directly use this one. You can directly specify the index from 0, 1, 2, 3, 4. And I will use this example to And I will use this example to illustrate how to use the array. And I made a mistake because the initial part is not correct. And in this example, I declare an array. This array has 3 elements, and I also assign initial value to the array. And later we will show how to assign initial value to array. And after I declare the score array, I want to modify the elements of the array. So in this example, I add 10 to each element of the array. And after the first for loop, then I print the value of each element of score. So the initial value of each element is 0, and in the first for loop, I add 10 to each element. So if I print the value of each element, the value of each element will be 10. You can change the expression. For example, I can change this with this I. Then you can see what happened. So the value of each element becomes 0, 1, 2 because I assign the value of index I to each element in the array. And you will find using array is convenient because if you don't use array, for example, if I don't use array, I need to declare 3 variables. And if we don't use array, for example, if we don't want to use array, then you need to manually declare 3 variables. And if you have 100 variables, it is impossible. It is very difficult to write program. And using array is also convenient. For example, I want to change I with I times 10, and I only need to change this line. But if I don't use array, I need to change 3 lines. I need to change 3 lines. So from this example, we can see using array is more convenient because you don't need to modify many lines. If we want to change the value of each variable, so using array is convenient. But there is for beginners, you need to make sure the index I is within the reasonable range. For example, if you declare an array with 3 elements, But you want to access more elements. For example, you change the less than operator to less than or equal to, and let's see what will happen. And again, it is legal to write. It is legal to write this expression, but when you run the program, you will encounter runtime error. So after I run this program, there is some error message, stack summation detected, because the array only has 3 elements. But I want to access when I is 3. When I is 3, then this line becomes when I is 3, then this statement becomes this one, and it is, and we cannot, and this element is outside the array, because this is the fourth element, because the index begins from 0. So score bracket 3 means the 4th element of the score array. And we only declare 3 elements. So the array, the capacity of the array only has 3 integers. And if we want to assign value to the 4th element of the array, this will cause runtime error. So this will cause stack summation detected. So we need to pay attention to the range of the index. The array index, the array index begins from 0, and 0 is the first number to computer scientists. For many programming language, the index begins from 0, but for some programming languages, such as MATLAB, the index is from 1, not 0. But for C++ or C programming language, the index is begins from 0. And C++ will let you go beyond range. This means if the index beyond the reasonable range, it is legal to compile your program. It is legal. The syntax is legal, but this will produce unpredictable results. For example, when you run your program will crash. For example, if I use the Windows operating system, if this operating system have this pitfall, then when I run this operating system, then this operating system will break down and maybe show the blue screen, and you can when the operating system breaks down, all of your programs terminates. So this type of unpredictable results are very serious, and the compiler will not detect these errors because these errors are legal. The syntax are legal, so the compiler will not detect these errors, and it is the programmer's responsibility to keep the index stay in range. And for beginners, beginners often commit a common mistake is to let the index beyond the reasonable range. For example, if you change the greater than to greater than or equal to, then this will you see that if I change the greater than to greater than or equal to, then you will see some unexpected results, because you see that I print the values of each element in array, and the first three values are expected, but the last value is a random number, because square bracket 3 is outside the array, and its value is not specified. So the value outside the array is a random number. So it is important to keep the index variable inside the range. Otherwise, you will encounter runtime error or the error like this one. You might access some random number you don't know. And in this slide is another example. The second example is to find the largest element in an array. And you can try by yourself how to, given an array, how to find the largest element. How do you find the largest element? We don't need to sort the array because sorting is time consuming. To find the largest score, we don't need to sort the array. We can use the following. Code. First, I declare a variable max score to save the max value of the largest score, and I assign the first element of the array. I assign the first element of the array to the initial as the initial value of max score. And next, I write a for loop, and there is one index. The index begins from 1. Because we already used the first element, so here index begins from 1. Because we already assigned the first element to max score, and in each iteration, the index is increased by 1. And the Boolean expression is I is less than 5, and 5 is the size of the array. And inside the a body statement is one if statement. This statement checks score bracket I and the max score. If the value of score bracket I is greater than max score, then we will assign the value of score I to max score. And so finally, after the for loop, max score will have the value of the largest score. After the for loop, the max score will have the largest score of the array. I think this is the most easy way to find the largest score of an array. And you can try by yourself. Can you have a better way to find the largest score of an array? And time is up, and let's end here.